Hi everyone. I'm planning to start a new series, which I call it Life Lessons from Electrical Engineering. And the reason why I started this, or I will start this series, I strongly believe that we engineers uh, our mind works in a very systematic way, math, physics driven. But in social life, or in life, generally speaking, it doesn't go this way. It goes in a different mindset. So I thought that if I can relate some of the things that we really understand, some concepts in electrical engineering, that we can grasp and we really deeply understand it, we can reflect upon some other general lessons from our life. And the first lesson or the first topic that I'd like to talk about, which is find your resonance frequency. Find your resonance frequency. Resonance frequency in electrical engineering is a very well-known concept. So I will discuss it from the circuit. I will just give a little bit of technical background just in case if you don't know it, and then I will move to the derived lesson from that concept. So if I have a circuit that has an R, resistance, inductor, and capacitance connected in series, and I am applying an AC voltage, sinusoidal voltage, and I want to find the current. Now, as we know that the impedance of the inductor is J omega L. So it's a positive imaginary number that is linearly proportional to the omega. And the C, the impedance of C is minus J over omega C. So it is a negative imaginary number that inversely proportional with omega, which is the frequency. So at certain frequency, this this part and this part will be equal, and hence they will cancel each other. As a result, the current value will be very, very high. As we know that from Ohm's law, I is equal to V divided by the total impedance. So at certain frequency, the impedance become minimum because these two will cancel each other, and hence you will have a jump of the current at that specific frequency, which we call it the resonance frequency. So in other words, there is certain frequency in the circuit at which you will get the maximum output. And I'm quite sure that in other engineering disciplines, they have something similar in civil, in mechanical, but I will not go there because that's not my field, but you can relate to the same concept that the system that you have at certain frequency, it behaves at its maximum peak. Now, I'd like to take this concept and apply it to our life. And the example I'd like to talk about is finding the best career that suits you. So this presentation is mainly for engineers, young engineers who started looking around and trying to find what is the best job for me. So I will take this curve, and where is the x-axis is the frequency, the y-axis is the current or the amplitude or the performance of the circuit that I want to measure, and we have something like this. I will take this and I will modify it and make it related to what I'm trying to talk about, which is related to the job. So in the x-axis, it will be the job type. We have many jobs for the engineers. Could be sales, technical, academic, if you want to continue and do postgraduate studies. And in the y-axis is your job performance. So what I strongly believe in, there are certain jobs, which is your resonance frequency, that your performance will be at its best. You will excel, you will have passion, you will love coming to the work, you will be creative, you will enjoy what you are doing. However, if you try to do something else, for example, for that specific example, if you try to do sales, your performance will be highly attenuated because that's not your resonance frequency. Now, in the previous circuit here, I know the value of L, I know the value of C, so I can calculate omega. There is a formula for that. Okay, but In real life, I don't know where is my resonance frequency. So what you do, if I give you a circuit that you don't know the value of L, you don't know the value of C, how you can find the resonance frequency? You can by using a sweep frequency, meaning that you apply your sinusoidal input and you change the frequency until you hit the frequency at which you will find your maximum or the maximum current. Back to this example, that's what you need to do in life. Sometimes the first job you select is your resonance frequency, but this is unlikely, unfortunately. Most of the time, maybe you are here, you are there, you are at different points, so you can make a living. That's okay, but you are not enjoying. That's not your resonance frequency. So what you should do, if, for example, you are at university like ours at University of Waterloo, we have co-op system. Try different jobs, try to do different things, and try to see yourself, because the only way to find your resonance frequency is to try. You have to do the frequency sweep. You have to try different jobs and watch yourself. Which one is best for you? Am I person that should do technical, maybe non-technical, or should I go to academia? In technical, should I do design, R&D, or maintenance, commissioning, and testing? In sales, should I become a leader or just a salesperson? We are different. And what is good for me may not be good for someone else, and so on and so forth. So that's something really very important question in our life, that what is my resonance frequency? The final thing also, I will also borrow it from electrical engineering, that when you see the performance, some of us, we have what we call the bandwidth. We have a very short bandwidth, small bandwidth, meaning that we can excel in very small, limited number of jobs. That's it. Some of us, they have a very wide bandwidth that they can do a lot of things. They can excel in many different jobs. You see people, there are some people, and there are few of them, not too many, they are excellent in technical and non-technical jobs. But most of us, we have small bandwidth. Most of us excel on a specific types of jobs. So my final conclusion here, this is the most important question in your career that you have to answer, and you are the only one who can answer this question. What is my resonance frequency?